and welcome everyone. So today I'm going to tell you about the electric dipole. Electric dipole. So when two equal and opposite charges are separated by a small distance, then that is known as the electric dipole. See, if we have two charges minus q and plus q and there is some distance between these two charges, then we can say that it is an electric dipole. So here this is the midpoint of the distance between these two charges. So from the minus q to the midpoint the distance is a, and from the plus q to the midpoint the distance is a. So the distance becomes 2a. It is an electric dipole. So in an electric dipole the magnitude of both the charges will be the same. We cannot consider a pair of two charges with different magnitudes. See, if here it is minus 3q and here it is plus 2q. So we can't say that it is an electric dipole because the magnitude of both the charges will be different in that case. And if we take that here it is minus 2q and here it is plus 2q, then in this case we can say that it is an electric dipole because the magnitude of both the charges are same. So now where they are seen. So in many molecules the center of positive and negative charge do not coincide, so there is some distance between them. Such molecules behave as permanent dipoles. Dipoles means they have distance between them. For example, in water, HCl, and in ammonia. So in the water molecule has 3 atoms, 2 hydrogen atoms and 1 oxygen atom, and the center of positive hydrogen and negative oxygen charges of the water molecules lies at different points. Hence we can say that they possesses a permanent dipole moment. So as you can see that this is an oxygen, it has negative charge, and these are hydrogen with positive charges. This is an oxygen atom and these hydrogen, there is some distance between them. So it is 0.958 Armstrong. So 1 Armstrong is equals to 0.1 nanometer or 10 raised to power minus 10 meter. So it is very small. There is some distance between the oxygen and the hydrogen atom. Similarly in the case of HCl, so chlorine is a negative ion and hydrogen is positive, so there is some distance between them, so it also possesses an electric dipole. Now let us talk about the one more related, that is dipole moment. Dipole moment, so it is the product of the magnitude of the charge and the distance between the centers of the positive and the negative charges. See, if we have the two charges minus q and plus q and there is some distance, so the dipole moment is the product of one of these charges and the distance between these two charges. So it is represented by the p vector. So the dipole moment is equals to q into 2a. Here q is the charge, any one of the charges. We can take minus q also, but here we have taken the plus q into the distance, that is 2a. So its dipole moment is q into 2a coulomb meter. So it is a vector quantity and its direction is from negative to positive charge. We always take dipole moment from the negative to the positive charges, as you have seen in the earlier examples also. See, in here we have discussed that here also dipole moment is from minus charge to the positive charge. Similarly here from the minus charge to the positive charge. The dipole moment vectors lies along the line joining the two charges and is directed from minus charge to plus charge. See here, it is from minus charge to the positive charge. Positive, its unit is coulomb meter or dBi, and the value of 1 dBi is equals to 3.336 into 10 raised to power minus 30 coulomb meter. The SI unit of dipole moment is coulomb meter, and the magnitude of the electric dipole moment is equal to the product of the magnitude of one of the charges and distance between them, as I have told that we take any one of the charges and the distance between them. So its magnitude is equals to 2a is the distance and q is the charge, any one of the charge. So this is about the dipole moment. So now let us solve some of the examples on how to find the dipole moment. So this is the example, and in this we have to calculate the electric dipole moment for the following charge configurations. So it has 4 parts, and in each part the charges are placed at different points. So it is possible to define and calculate the electric dipole moment for a single charge, 2 positive charges, 2 negative charges, and also for more than 2 charges. So here for the simplicity the 2 charges are placed on the x-axis, and even if the 2 charges are placed on the y-axis or the z-axis, the dipole moment will always point from the minus charge to the positive charge. So here in this part we have to calculate the electric dipole moment. So this is the origin, and it has two charges, plus q which is placed on the minus x-axis, and this plus q which is placed at the positive x-axis. So we have to calculate its dipole moment. So its dipole moment is q, as we know that dipole moment is equals to charge into the distance. So it is q into a into minus I cap, because I cap is the unit vector in the x direction, and for this charge the dipole moment is q into a into I cap, positive I cap. For this it has minus I cap, and for this we have plus I cap, because it is in the positive x-axis and here it is in the negative x-axis. So the dipole moment will be the sum of this dipole moment. The total dipole moment will be the sum of this dipole moment plus this dipole moment. The position vector for the plus q charge on the positive x-axis is ai cap, and position vector for the plus q charge on the negative x-axis is minus ai cap. So the dipole moment is, see, q into ai cap for this charge. This is the dipole moment for this charge, and for that charge we have q into minus ai cap. This plus minus get cancels each other, so we get 0. So this is the dipole moment for this configuration. And in the B part we have these two charges, in which one charge is placed at the origin. So its position vector is 0 because it is at the origin. So it is q into a into I cap. I cap is the unit vector in the x direction. So in this case one charge is placed at the origin, so its position vector is 0. Hence only the second charge plus q with position vector ai cap contributes to the dipole moment, which is dipole moment is equals to q into ai cap. It is just because of this charge. So this is the answer. So from both cases A and B, we can infer that in general electric dipole moment depends on the choice of origin and charge configuration. So dipole moment depends that where the charges are placed, whether they are placed at the origin, so the position vector is 0, or whether they are placed on the y-axis or the z-axis, and its charge configuration. This is the C part, and in this we have to find the electric dipole moment. So as we can see that there are two charges, minus 2q and q, and we can see that these are placed on the, this is placed on the y-axis, this is placed on the minus y-axis, and as we know that the electric dipole moment, it is directed from the minus charge to the positive charge. So we have to find its electric dipole moment. So this is the origin. So from origin to this charge, the electric dipole moment is minus 2q a into j cap. J cap is the unit vector in the y direction, and for this we have to take minus q into 2a and minus j cap, which is the unit vector in the minus y-axis. So when we add both of these dipole moments, we can get minus 4q a j cap, the minus 2q into a j cap. This is for this charge, this is the dipole moment for this charge, and for this charge q into 2a into minus j cap. For the total we have to just add these two dipole moments, and this minus minus get plus, so that is minus 4q a j cap. So this is the answer. So we can note that in this case dipole moment is directed from minus 2q to plus q, because it is from minus charge to positive charge. It is directed, that is dipole moment is directed. And in this part we have three charges, minus 2q, q and q. So from here to here the dipole moment is q into a into j cap. For this q into a into minus j cap, and for this minus 2q into a into minus I cap, because for the x-axis we take the I cap. So for the overall dipole moment we have to just add all of these three dipole moments. So we get minus 2q a minus I cap for this charge plus a j cap for this charge. This is the dipole moment for this charge, and for this charge the dipole moment is q into a into minus j cap. So when we add this we get 2q a I cap. So this is the answer, or we can say that this is the dipole moment for these three charges. So this is about the dipole moment. Thank you everyone for watching, and if you have any confusion or doubt you can ask me in the comment box.